So we don't use diameter for most of our calculations, especially when we do volume. Diameter doesn't help us in volume. So for us, the first thing you should be doing for most of these questions that are giving you diameter, um, you want to be able to take that diameter and divide it by 2. Whoops. To get your radius. The radius is what you want to work with, right? Radius is specifically what you want to work with. So once you have the radius down, then we can figure out the height of the can. We've done this before, but since there are 3 balls, there are 6 radiuses for the height. So for the height here, right, this height here is equal to 6r, 6 radiuses. So the height, which is equal to 6r, is just 6 times 4.2. And so h is equal to 25.2. Okay? Are there any questions about that? I don't think that one's particularly difficult there. So we have 25.2 centimeters as the height of the canister. Now for the volume equation, right? For the volume of a cylinder, it's 2 pi r h. Oh, sorry, pi r squared h, right? So for the volume of a cylinder, if you look at your formula sheet, it's pi r squared h. Okay. So we can plug in all the values that we know. And then we have r. You don't see where you can. It's called scatter plots and LOBF. It's under quizzes, tests, assignments. It's on the very top. It's called scatter plots and LOBF assignment. R is 4.2 squared, and then H is 25.2. We can then do the multiplication. 4.2 times 4.2 times 25.2, 423.36 pi, and we multiply that out. 423.36 pi times pi. And we get 1,329.35. Are we done here? Is this question done? Yes or no? No, Elia's right. It's not. Why? What do I have to calculate next, Elia? No, not the therefore statement, actually. If I write the therefore statement, I'm still not done the question. Well, you're right. It's not done. So Elia's right. It's not done, but it's not because of the therefore statement. What does the question actually ask us for? How much space is left in the can? Not how much space is in the can, it's how much space is left in the can. Right? So the issue that we have here is we found the volume of the can. We didn't find the volume of the tennis ball. No, we didn't. So we need to find the volume of the tennis ball. So volume of ball is equal to, right? 4 pi r cubed divided by 3. Okay? So you gotta read the question carefully. If I didn't say that, I don't think some people would have caught that, right? So it's very important that you read the question carefully. right? It's like, oh, we've seen this before. Like if you remember on surface area, we did this question. Like it had 3 tennis balls in it. We were supposed to find the surface area, and some people might have assumed, hey, that's the same question. We must be finding the volume of the can. Haha, funny. No, it's not. Right? The idea here is you read the question carefully. It's not asking for the volume of the can, it's asking for how much space is left in the can, which means we have to find the volume of the can and subtract the volume of the tennis balls. So let's calculate the volume of the tennis balls. We know the radius is 4.2 as well here. And then we divide that by 3. So 4.2 times 4.2 times 4.2 is 74.088 times 4 gives me 296.35. All divided by 3. We can do all that math here at once, right? So 296.35 times 3.14 divided by 3. That gives me 310.18 centimeters cubed. Okay? So there's our second step. Our third step is to find the volume of the space, which is going to be equal to the volume of the cylinder subtracted by 3 times the volume of the ball, because there's 3 balls in there. Does that make sense? So we take the volume of the cylinder, we subtract the 3 balls that are inside, and we're going to get the volume of the empty space there. So we do 1,329.35 minus 3 times 310.18. We can calculate that out by multiplying following bed mass. 3 times 310.18 goes first. That's going to be 930.54. So 1329.35 minus 930.54. And that's going to give me the volume of the space, the empty space. So 1329.35 minus 930.54. And that gives me 398.81. So 398.81 centimeters cubed. And then what Elias said earlier, we need our therefore statement. So therefore, we can finish it off here. Therefore, there is 398.81 centimeters cubed of empty space in the can. And voila, we've gotten our question. Answer. So this question that we thought was simple at the very beginning turns out to be a little bit longer than expected, but it's important for you to read the question carefully, solve for exactly what you're looking for, and then remember to, well, for in this case, subtract, right? Oh, Kuzli, welcome. Glad you can join us here. Don't worry, you're technically not the latest person. All right. Example 4. Okay. Oh, sorry. Before we go to example 4, are there any questions on example 3? All right. So there's no questions for example 3. Example 4. Ooh, hoo, hoo. I love this one. Example 4. You can take this in 2 different ways. You can solve example 4 in 2 different ways. Okay. And it's, let's see if anyone gets it. The one thing I will tell you about this, right, with example 4 is that you solve it the same way we've done for, area and perimeter of composite figures, like 2D figures, where we numbered like, oh, this is area 1, this is area 2. So you do the same thing here. I'll say, oh, the cone is volume 1 and the cylinder is volume 2. Okay, so number the figures that you see, right? The shapes that you see, you should number them. 100% you should number them. and then you work with what you have. Now, it already gives us the volume of the cylinder. Okay? So I'm going to give you guys 3 minutes. Okay, no. Yeah, 3 minutes. I'm gonna give you 3 minutes to solve this question on your own real quick before we take it up. Try it. I will say, for those who are able to see it, and remember the lesson I told you, hint, scroll up to the top. Well, I say scroll because I'm on a computer. Go to the front page. The hint is there. If you're able to get the idea here, you should be able to solve this in less than 30 seconds. And I'm not kidding. Like, I'm not. That's not a joke. Like, every single person, if they understand what the concept on the first page, you should be able to solve this in less than 30 seconds. But if you can't, that's okay. We're gonna do both ways anyways. All right. So try giving this a shot. 3 minutes. I'm gonna put the timer on the screen now. We'll take it up. Timer is on now. See you in 3 minutes. And with that, time is up. All right. If you didn't finish, that's okay. For those that did finish, well done. Maybe you caught the quick shortcut that you were supposed to do. So let's do the shortcut way here. And the shortcut way was very simple. The volume of the cylinder is equal to 96 centimeters cubed. If you remember, at the very first page, I said this. Scrolling up to the first page, I said, hey, if the prism and the pyramid have the same dimensions, then the volume of the prism is a third of the volume of a pyramid, and the volume of a pyramid is one third the volume of a prism. And we specifically use cones and cylinders as well as pyramids and prisms. We have a cone and a cylinder. And the cone, in our case, has the exact same measurements as the cylinder. The radius is shared, and the height is shared. It's 4. Which means we can say the volume of the cone is 1/3 the volume of the cylinder. Or I'll specifically use this, which allows me to do this, and I can get the volume of the cone very quickly. 96 divided by 3 gives me 32. And there, we have the volume of the cone. Once we have that, what's the volume of the figure? Well, the volume of the figure is the volume of the cylinder plus the volume of the cone. And that's going to be 96 plus 32. 96 plus 32. So, and what's that going to give me? Well, that's going to give me 128. Okay. So, boom. The left side that you see here was the shortcut way. Are there any questions about that shortcut way? All right, looks like there are no questions about the shortcut way. All right. The longer way is as follows. You're given the volume of the cylinder, and the height is 4. To solve for the volume of the cone, you need the radius. You don't have the radius. So, but you do know that the volume of the cylinder is equal to pi r squared h. So if we plug in all of our givens, we get this. Or specifically, like that. We can then divide both sides by 4 pi to get rid of it and move it, and we're isolating for r. We want to solve for radius. So in doing so, 96 divided by 4 divided by pi gives me 7.64 equals r squared. We then square root both sides, and that's going to give me my radius. So that's going to give me 2.76 rounded. So 2.76 equals r. We now have the radius, and so now we can plug this into our volume for cone formula. So the volume for the cone is pi r squared h divided by 3. Plugging it in, pi times 2.76 squared times 4. Then we multiply it out. So 2.76 times 2.76 is 7.61.76 times 4, 30.47. So we get 30.47 pi. So that's 2.76 squared times 4 gives me 30.47 pi. And multiplying that out gives me 95. Oh, whoops, I forgot to add the divided by 3. Whoopsies. Sorry, guys, 1 second. Silly me. Silly me. Sorry, 1 second. Forgot to add the divided by 3. Okay, so 2.76 times 2.76 times 4. We get 30.47 pi divided by 3. We then multiply that out, 30.47 times 3.14 divided by 3, and we get 31.89, which can be rounded, right? We know that it can be rounded, so that's approximately 32. And we should get the same answer, essentially, right? So it's pretty close to 32. Notice how it's closer because we've taken so many estimates. When we solve for situations like dividing it by 4 pi, square rooting, dividing it by 4 pi, right? The issue that happens with these calculations, the reason why it's not completely the same as the 32 here, is because we're taking decimals and we're rounding it every time. And the more you round, the less accurate it gets, right? So there is going to be a discrepancy versus what it's supposed to be, which is 32. But that's to be expected. We're rounding a lot. So, but in the end, we get the answer similar to it, which is what we want. And you should still get the volume of the figure. The total volume is equal to approximately 128 centimeters cubed. So look at this. No matter what method you do, you'll get the right answer. It's just, let's be honest, for those that understood the shortcut, they just did it a little faster. But does that mean you're bad at math? No. Honestly, if you did the right side, you're just as good as math because, well, you did the harder method, did you not? Right? Just because you're slower doesn't mean you're not smarter, right? And just because you're faster doesn't mean you're not smarter, right? Like both of them have their benefits, right? Doesn't That's why I keep saying doesn't matter which method you choose, but one method might save you more time than the other. But does that mean that method's 100% better? No, absolutely not. Right? The right side shows that you understand the algebra and you can solve it regardless of not getting the shortcut. The left side just also means, hey, I know how to do the math, but I remember that there's a shortcut to solve this faster, and I remember the shortcut, so I'm going to use that shortcut, which is a smart use of efficiency, right? Like how to be efficient in solving a problem. So both have their benefits. Get the practice with it, identify when you can use it, right? Which is specifically in this situation pyramids and prisms, right? So cones and cylinders, as well as um, pyramids and prisms, like rectangular prisms, triangular base prisms, that kind of idea. Yep. Oh, something's in my eye. Okay. Any questions about example 4? I don't understand how you got 128 centimeters cubed. Which one? The last one? I mean, if you really want me to show the work, it's the same one as before. You're literally just adding the two, which is the same stuff, right? 96 plus 32. You get the same thing. Do you get more grades for doing it the longer way? No. These would both be marked equally. So if this was both like if it was like a 4-mark question, 4 marks, regardless of which way you do it. Because it would make no sense to give 2 different ratings, I don't think. Any other questions? That's a really good question, though, Gerald. Thank you for asking that. All right, looks like there's no other questions. We're going to move to example 5. Example 5 here, it says sand is being poured from one container to another, shown below. The sand flows from the shaded part to the unshaded cone. The shaded part starts full of sand, and the sand empties into the unshaded cone and fills it to the top. What is the height of the unshaded cone? So, the important part of this question is this sentence. And fills it to the top. Okay? What does that mean? What does that mean? Well, that means that the volume of the shaded area is equal to the volume of the unshaded area. If it completely fills the cone, yes, Milana's saying it. Perfect. It's the same. It's exactly the same. It has to be, right? Because it fills it to the top. So the volume of the shaded is equal to unshaded. Now, how you want to label this is up to you. I see three shapes, right? I'm not going to work with shaded and unshaded. That's going to be a nightmare. I'd rather work with three shapes and I'll add volume 1 and volume 2 as my shaded area. So for me, I can then replace this and say, instead of saying volume shaded, I can say volume 1 plus volume 2 is equal to volume 3. Does that make sense? Right? I've numbered it 1, 2, and 3. The shaded area is composed of volume 1 and 2 added together, and the unshaded area is equal to volume 3. This allows me to identify what I'm trying to solve for, what shapes I'm trying to solve for, right? So this here is a cylinder, this here is a cone, and this here is a cone. So we have all of that. Okay. Now you'll also notice that this cone shape and this diameter shape are different, right? So please keep that in mind as you solve your question. So let's work with this stuff here. So let's work with volume 1. Let's work with volume 1. So for volume 1, it's a cylinder. So for volume 1 is pi r squared h because it's a cylinder. We know r, the diameter is 5, so r must be 2.5. Okay. So the diameter is 5, r is 2.5, and the height is 4 for the cylinder. Once we have that information down, we can then plug it in. Volume is equal to pi times r squared, 2.5 squared times h, which is 4. We can then solve that out, volume 1. So 2.5 times 2.5 times 4 is 25, so 25 pi. So volume 1, multiplying that out, 25 times 3.14 gives me 78.5. So boom, voila, we've done our first volume. Volume 1, we have it. We're done. We're magically done volume 1. Amazing. We're so smart. Our class is so smart. Volume 2. Okay? For volume 2, we have the cone. And the cone here is pi r squared h divided by 3. We cannot use the shortcut because the heights are different. So for this one, we cannot use the shortcut because the heights are different. Make sure you understand that. The radius and the height both have to be exactly the same. So since the height is different, we can't do it. So we do have to solve this manually. So the radius is still 2.5, but the height is 2. So plugging it into our formula, we're going to get pi times 2.5 squared times 2 divided by 3. And in doing so, 2.5 times 2.5 times 2 gives me 12.5. Divided by 3. Okay? So v squared, or v squared, v2, the second volume, 12.5 times 3.15 divided by 3 gives me 13.08. Or let's round it to the first decimal place, 13.1. Okay? So there's our volume there. Before we move on, are there any questions so far? Okay, looks like there's no questions so far. So what you do from here, we cannot solve volume 3. We can't solve that. And the reason for that is because we don't have height. And so that's why we stated the first equation here, volume 3, right? Let's rewrite this equation. Volume 1 plus volume 2 equals volume 3. Because the question is to find the height of the cone. So we want to find volume 3. So volume 1 is 78.5. Volume 2 is 13.1. And that's going to be volume 3. Adding these together, I get 91.6 centimeters cubed is equal to volume 3. That's beautiful. That's what we want. We need this. Okay? So now we have volume 3. Since volume 3 is a cone as well, we follow this volume. Not only that, we also know volume 3 is 91.6. R is 3 because we have the diameter as 6 at the bottom here, right? And we need the height. We need to solve height. So let's solve for height here. We have all the information we need. We'll plug it in. So 91.6 equals pi r squared, or 3 squared, times h divided by 3. We'll multiply the 3 squared first, just to simplify it. So 3 times 3 is 9, so we get 9 pi h over 3. We then have to isolate for h. Okay? So we follow BEDMAS backwards. This is just like we're doing algebra here. The first thing I'm going to move is the 3, right? Division, multiplication goes first, but if we have division, we get rid of the division first. So we're going to move the 3 to the other side. We're going to multiply by 3 on both sides. So I'm going to get 91.6 times 3 is equal to 9 pi h. And so 91.6 times 3 is 274.8. Is equal to 9 pi h. Then we can get rid of 9 pi. We can divide by 9 pi on both sides. And that gives rid of like the 9 pi on the right. And so we do 274.8 divided by 9 divided by 3.14. And we're going to get our final answer of 9.72 centimeters cubed is equal to h. So once we have that, 9.72 centimeters cubed is equal to h, we can then say our therefore statement. Therefore, the height of the unshaded cone is 9.72 centimeters cubed. And there's our final answer. Are there any questions about this? It's a lot. It's a fairly long question for something that seems so simple, right? Such a fairly long question for something that seems so simple. Okay, looks like there's no questions. We're going into our last example for today. Example 6. A figure is pictured below with is a cone with its top portion removed. Determine the volume of this figure and show your work. I will give you I'm going to give you 7 minutes to solve this until 9:70. but I will put a timer on the screen for you to look at it as well. So you have 7 minutes to try solving this question on your own, and then we will take it up as a class. And then once you finish taking it up, you'll get your break and we will start our work period. All right? So here we go. 7 minutes on the clock. All right, with that, time is up. Okay. If you did not solve it, once again, that is okay. That's what we're going it over for. Hopefully you gave it a try, though. The important part is you gave it a try. If you didn't give it a try, then I'm more worried, right? So you should at least have given this a try so that, um, you have something, right? Um, so yeah, let's do that. So, what are the two shapes that you see here? Type it in chat. It's not too hard to see. What are two things, two shapes that you see here?
Two shapes.
Yes, because whenever we're given a question like this, we have to see it. Perfect. Gerald said it. We have the bottom cone and the top cone. So I'll number them 1 and 2. I'm not sure how you numbered it, but I'm gonna number 1 and 2 like this, and we're gonna work with that, right? So we'll call like the radius of the top cone as like R2 and the radius of the bottom one is R1. Height of the top one is H2 and bottom one is H1, for example. So the main thing you want to realize is we're talking about the number one is the large cone, so the big whole cone, and then the second one's the small cone that's gone. So we already know, we can kind of write on the side here, we know that the total volume is going to be V1 minus V2, right? We know that we're going to have to subtract because that part is gone. That's disappeared. So we can keep that on the side and make sure we know that's what we're doing. So for V1, it's a cone, like was stated. So it's pi r squared h divided by 3. And let's write down what we know. We know what r is. It's supposed to be 4 because the diameter is 8. D1 is 8. So the radius is 4, or R1 is 4. And then H1, which is the height of the first cone, is 12. It gives you the whole height over here. Okay. And so we can plug that in. V1 is equal to pi times 4 squared times 12, all divided by 3. That allows us to quickly solve for our volume of the cone. So we get 192 pi divided by 3, and multiplying that all out, 192 times 3.14 divided by 3 gives me 200.96 centimeters cubed. Okay. So we have our first volume. Not bad. Very simple. Okay. The second volume requires just a little more work. So for the second volume, for V2, it's also going to be pi r squared h, but divided by 3. R2 is already given to us. That's 1 centimeter. H2, we need to do a little bit of a calculation, which is 12 minus 9.
3.
Right? And so, just like James said, that's 3. And so the reason why we do that is we know the height of the whole cone. We know the height up until the bottom of the second cone. So if we subtract the 2, we're going to get the height of the small cone. So there we have it. So we have 3. We can now plug it into our formula, pi r times 1 squared times h divided by 3. And, well, 1 squared times 3 is 3 divided by 3. And that's going to give me just pi, which is equal to 3.14 centimeters cubed. Okay, rounded. So once we have that down, we can now solve for our total volume. We have our total volume equation on the left there. Just going to copy it down here on the right. V1 minus V2. We know what V1 is. We know what V2 is. And doing the math, 200.96 minus 3.14 gives me 197.82 centimeters cubed. And there's our final answer. So therefore, The volume of the figure is 197.82 centimeters cubed. And there we have it. And that's going to be our final answer. Okay. So you had to find the volume of the first cone, which was not too hard. You're given all the values that you need, so you just plug it into the formula. You're given the volume of this. You need to find the volume of the second cone. You needed to solve for the height of the second cone because the only thing that was given was the radius. You solve for the volume of the second cone, and then you get the total volume by subtracting the two together. Are there any questions? Okay. So with that, we're going to take a 15-minute break. We're going to take a 15-minute break. After 15 minutes, would you guys like me to talk or say out loud each person that what they require to be complete? Or do you guys know exactly what you need to do this period? Sure, I can say that out loud. So if you
Yes,
guys don't
do
mind,
it.
I'm going to share that right now. Okay? James, I believe you already know because I sent you a message before, right?
Yeah, of course. I know what I'm missing.